Situated in Belvedere, Kent, Riverside 1 is one of the largest operational EFW facilities in the UK and the only one with river infrastructure for receiving waste. Cory processes up to 850,000 tonnes of non-recyclable, also known as residual waste, each year at our Riverside 1 facility. This residual waste comes from local authorities and commercial and industrial customers and is sent to our facility via the river network using 5 waste transfer stations. An important byproduct of the incineration process is steam. This steam is used to drive the turbine that can produce partly renewable baseload electricity. 239,000 tonnes of carbon is saved each year by not sending this waste to landfill sites. 936,000 tonnes of non-recyclable black bag waste is diverted from landfill, and 476 gigawatt hours of electricity exported to power the equivalent of 195,000 homes or a town the size of Norwich. So in my previous role as an asset integrity engineer, one of my tasks was to investigate some malfunctioning issues we had on some of our high pressure, low pressure and feed water systems. I learned about IMI Insyt through a company called GPEC Limited. I decided to commission a study at our facility due to repetitive water hammer issues within this system. IMI happened to be the OEM for the majority of the components that make up this system. Therefore, it made perfect sense to work with them.
The Riverside issue was quite interesting because the customer came up to us with with a specific issue of water hammers in the drainage pipe system. And we, of course, we had to identify the root cause. That's the first thing. That means we collected a lot of data. We collected operational trends for about 1 year operation period of the whole plant, and we analyzed the behavior and the situation, and we identified what are the root cause or what are the contributors for water hammers in drainage pipe systems. And there are basically 3 contributors, which is excessive flows or excessive flow velocities and sudden changes in pressures and temperatures. We found the problem that they create a lot of condensate because the bypass station is always in standby mode. That means the piping system, the upstream piping cools down, and when the process station comes into service, then the hot steam passes by the cold system. That means a lot of condensate is produced, and this is the contributor number 1, excessive flow and flow velocities. And secondly, the shutoff valve upstream created pressure shocks. And third, then of course, before the system was cold, finally the hot steam is coming, we have also thermal shocks. So all the 3 contributors were existing, were identified, and based on that we came up with the solution. First, to install a breathing system to keep the overall system at a certain temperature to prevent condensate formation when the system is in standby. The second thing was to change the control logic for the shutoff valve upstream. And the third one was to improve also the injection technology. We moved from an internal injection to a downstream injection system. And the fourth recommendation was to upgrade also the water injection control valve, because this valve was not able to control low flows. That means the rangeability of the water valve was not designed to control the entire operating range.
So thanks to the recommendations from the Insyt studies, we have now improved our net efficiency by 1.5%. Our electricity export per tonnes of waste improved by 0.45 megawatts. Our generation improved by 4 to 6 megawatts per hour. The lost opportunity in revenue in Q1 of 2024 before the project was implemented equated to 10,300 megawatt hours. The return of investment for this project was 1 month. So since the completion of this project, we've had no further water hammer events. We have improved operational control of the components. We have no further equipment component damage or defects. We've improved equipment stability and reliability, reduced losses and improved efficiencies. I've been working closely with GPEC and IMI for the supply of goods and services. Both companies have high standards and exceptional technical knowledge, which has greatly contributed towards the success of this project. GPEC and IMI's dedication to maintaining the highest quality in their products and services has consistently surpassed our expectations. The team at GPEC and IMI have proven invaluable, ensuring that each deliverable meets or exceeds industry standards with their expertise and technical prowess. Both GPEC and IMI have consistently demonstrated a helpful and collaborative approach, fostering a strong working relationship whenever challenges arise. GPEC and IMI have proven to be a reliable partner, always ready to provide insightful solutions and support. Their proactive and responsive attitude has undoubtedly played a pivotal role in the smooth execution of this project.